Do you know one of the important reasons most organizations are not able to be fully data driven is that a major portion of data generated today is unstructured? That is, data in the form of videos, images, and documents remain untapped by organizations because of the complexity involved and the amount of resources they need to bring in the systems to integrate them with other existing analytic solutions. One of the goals for Google Cloud is to help organizations realize value from data of all formats and types. Late last year, we announced the preview of this feature, that is, to be able to store unstructured data in BigQuery and also perform machine learning and analytics on top of the data using BQML, which is BigQuery ML. My name is Abhirami Sukumaran, and this session today I'll discuss how to achieve image data classification using only SQL queries with BigQuery ML. So what's unique about processing unstructured data with BigQuery, you ask? You can store unstructured data in object tables just like you would with regular tabular data, perform analytics and machine learning on image data only using SQL queries, unify structured and unstructured data at scale and query them together. There are 5 steps in achieving image data classification with BigQuery ML. Create dataset and big lake connection, create a cloud storage bucket and grant permissions, create an object table, create a model and upload it to Google Cloud Storage, load the model into BigQuery ML and start predicting. Let's get into the steps. The first one, which is creating a dataset and a big lake connection. If you're following this code lab, you can just copy paste this SQL to create schema, project ID, which is your Google Cloud project ID, and a name for your dataset. In this case, it's yoga_set. Once this is complete, go ahead and click the Add Data button on the Explorer section of BigQuery in Google Cloud. So you can go to BigQuery in Google Cloud by searching for BigQuery on the search bar in console.cloud.google.com. And on the left, you'll see the Explorer pane, and to the right, you'll see the BigQuery query editor pane. On the Explorer pane, you see the Add Data link. Click that, and it should open up the external data source pop-up where you select the connection type, which is Big Lake and remote functions. You provide a connection ID, and you'll select a location type. Make sure this location type is same as the location that you have provided for creating the data set. If you have not mentioned anything explicitly there, it would be US, and here also you can set it to US. And once it's and click create connection. Once it's completed, you should take a note of the service account that gets created when you create this external data source connection. We will require the service account because we need to grant permissions for this service account, so it allows BigQuery to access the Google Cloud Storage buckets. Moving on to the next step, which is creating Google Cloud Storage bucket and grant permissions. To enable this, go to the search bar in Google Cloud Console, search for cloud storage, and click that from the list that you find in the search bar. And on the left, you should see buckets link. Click that, and it will list the already available buckets in that particular project if there is none, or if you would like to create a new one. Create a new bucket, provide the name of the bucket. In this case, it's yoga_poses. Make sure the region is same as the region that you've provided for BigQuery and the external connection. Once you provide the details for the bucket, click create. Once the bucket is created, you would be able to upload image files for the images that you want to perform the classification and prediction on. Find those publicly available images or your own images that you want to perform this data processing on, and store them in Google Cloud Storage bucket. Storing images is pretty straightforward. You have 2 buttons, one for uploading files and one for uploading folders. Click the button to upload files and upload your images there. Or if you have it inside a folder, just upload it by clicking on upload folder from your local on Google Cloud Storage bucket page. Once it's uploaded, you should also take a note of the bucket name and path from Google Cloud Storage bucket configuration page. Once the bucket is created, images are stored, and you have noted down the path, the GSUtil path of the bucket, you're all set to move on to the next step, which is granting necessary permissions for the connections service account to access these images. Run these two steps in Google Cloud Shell. To access Cloud Shell, you can go to the top right Cloud Shell icon that you see on Google Cloud Console and replace these two placeholders, the service account with the value that you have noted in the previous step and the GSUtil bucket path with the value that you just noted down from the bucket link here. Moving on to the next step, creating an object table. Now that we've created a BigQuery dataset, created a Big Lake connection, created a Google Cloud Storage bucket and granted permissions, the next step is to create BigQuery external object table. To do that, copy paste this SQL and run it in BigQuery query editor as shown right here in the screenshot. Make necessary changes here, provide the right data set that you just created, provide a table name. In this case, I'm creating a table with name yoga_poses, and provide the connection name with the value that you provided at the time of creating the external Big Lake connection in step 2. And for URIs, you have to provide the GSUtil path of your bucket, which we noted in the previous step. Once the table is created, you should note that the table along with the data, the image data that is available in the buckets, the reference to that is created in BigQuery. Let's quickly query that and confirm that the data is available in that table. So select data, URI from yogaset.yoga_poses, which is the dataset name and table name respectively. So once I run this query, I get one row from yoga_poses table. Now that we have created the external table and confirmed that the data is transferred, let's just visualize this using a small Python code snippet. What you can do here is you can click Save Results right here, the drop down right here, and select it as CSV local file. Just for the sake of this demo, you can also programmatically achieve this using your own programming language of your choice. And here I'm just saving the CSV local file and uploading it in my Google Colab notebook. And I'm running the small snippet right here to visually validate that the image file that is referenced in the select query right here actually refers to the downward dog pose and the data is actually available. It is just a visual representation of the select query that I ran before using a Python snippet. So that's about it. Moving on to the next step, which is creating the model and uploading it into Google Cloud Storage. For this, we are going to use a pre-trained ResNet 50 model to run inference on the object table that we've just created. You can use your own model that you want to create for your images. Make sure it's uploaded in TensorFlow Hub and it's available there so that you can download it to your local and push it into the Google Cloud Storage bucket where your images are stored. In this case, for this code lab, you can download the model that I'm referencing from the location that's available right here, the TensorFlow Hub. You can reference this code lab for that. It should unpackage into saved_model.pb and a variables folder in your local. Upload these two into the bucket that we created in the previous section where you're storing your images. Upload these two in the same folder in Google Cloud Storage as shown in this image right here. Once that is done, now we've created the model in cloud and uploaded it in Cloud Storage bucket. The next step is to load that model into BQML and start predicting. For this, we are going to run this create model SQL. Create model dataset, which is yoga_set, model name. In this case, I'm creating a model named yoga_poses_resnet. And we leave the model type as TensorFlow and model path as replace this with your GSUtil buckets link that we have stored in the previous step, one of the previous steps. As you can see right here, once the model is created, you should see this statement that it will create a new model. Before it gets created, you will see the statement that it will create a new model named yoga_poses_resnet. And once it's created, you should see a button that says go to model. Once you click that, you should be able to expand the data set and click the schema tab where you see labels and features. Labels should contain a field named activation underscore 49, and features should contain a field named input underscore 1. Activation underscore 49 refers to the target variable, which is the output that you get from the model, and features, which is input underscore 1, refers to all the independent variables, or in this case the data set that you're passing in as input. And that's about it. The next step is to use the model and start predicting a random or existing data from your BigQuery external table. So for this, we will use the ml.predict SQL, select star from ml.predict, and you pass in the model name, dataset name.model name. And then then you pass a subquery that actually references the data for which you want to predict using this model you've just created. For that, I'm just taking it from the existing table yoga underscore poses from a specific folder called downdoc and a specific image. This is still in the yoga underscore poses external table. So I'm running this query, and once the execution is complete, you should see the result in this format, which is heavily nested. As I said before, activation underscore 49 is the target, which is the result, the predicted result. URI is the image that I actually passed in for prediction, and these are all the input field variables values. So this is highly nested, so I just wrote a simple flattening query to flatten the result. So in my case, I have applied a sample logic to get the label in the form of integers as well as the label in the form of text. That's it. So this model has successfully inferred that the image we passed in is down dog, and here is a score for the inference, and also to visually infer the same result using the same method that I told you before. Use a small Python snippet so you can validate that the model result is in fact right. That's it. We've now completed the ML model creation and prediction using BigQuery ML with just SQL queries. And the next part is where you unify structured and unstructured data and just query them together. I've created a structured relational table with 4 fields. It's just a straightforward, easy fields, all string fields to represent the pose, what physical part of your body it focuses on, and what health benefits the particular yoga pose has, and what is the breath for that particular pose, whether it's an inhale pose or exhale pose or either. So this is the select query that unifies the structured data, which is the health benefit, which is the yoga underscore health table. And it also references the unstructured data table, which is yoga underscore poses, which stores the images which we saw before. So we are joining these 2 tables on the pose name field, and below is the result, as you can see right here. It's fetching down dog with health benefits, breath, focus, and the data, which is actually a reference to the image, which you can then run through your Python snippet, and or you can do the whole SQL querying part for this entire exercise using BigQuery magic commands. So that way you can run these queries directly on your Collab notebook rather than switching between your BigQuery editor and your notebook. Congratulations, you have successfully stored, queried, and performed ML on image data using BigQuery ML. And if you'd like to innovate and share ideas, please feel free to connect with me at abhirami.dev. You can find this code lab at abhirami.dev/codelabs. You can also scan the QR code to land in this page. Also, there is a link to register to become a Google Cloud Innovator or Google Cloud Innovator Champion, and the link to that is available on the homepage of abhirami.dev. Please feel free to register and become a Google Cloud Innovator today.